Let's look at game 6 from homework 7. So again, as always, we look for dominant strategies. Player 1, if he goes up, he's a lefty, he goes up, he gets 1, he goes down, he always gets less than 1. So this is a dominant strategy. And for player 2, if he goes up, he gets 0. If he goes down, he also gets 0. So player 1, if he's a righty, gets the same no matter what, so we really have no idea what he is going to do. What about player 2? If he picks X, if he knows he was on the left, he'd be for X, and if he knows he's on the right, it doesn't matter to him. So X is weakly dominant, but he doesn't have a dominant strategy. And for player 2, if down is played, he gets 0 no matter what. We know he's always indifferent. We have no idea what he's ever going to do, and he certainly doesn't have a dominant strategy. Now, finally, for figuring out what player 2 is going to do up here, we know he's going to pick X because he's either in an equilibrium in which lefty goes up or lefty and righty go up, and either way, you are better off with X. So if nature picks left, we end up here, and if nature picks right, we don't know where we'll end up. Okay, game 7. For game 7, again, look for dominant strategies. If up is played, 5 or 8, down is played, always less. Up is a dominant strategy. What about if you're lefty? Up is a dominant strategy. For right, up gives 0 or 2, down always 1, so there is no dominant strategy. For player 2, if you were here, you'd want X. If you were here, you'd want Y, no dominant strategy. And for player 2, if you were here, you would want, you would be indifferent. And if you were here, you would want X, but we have X as weakly dominant. We don't have X as strictly dominant. But we can still use the trick that if someone goes down, it's not going to be lefty. So if down is played, player 1 can be confident he's on the right, and at which point he would definitely want X. This, unfortunately, is not enough to tell us what righty would do, because righty, he goes down, he gets 1. If he goes up, he could get more or less than 1. And let's see if we know what will happen up here. We will say if just lefty went up, player 2, and if up is played, would want X, but if lefty and righty went up, then player 2, if you worked out the probabilities, would want Y. So we need to use the take a chance. Let's do the take a chance. I'll put a square here. And with take a chance, let me move this a bit, see if I can. No. All right, sorry about that. So let's see if this can work. In an equilibrium in which everyone goes up, player 2 here would respond with Y. Right, and that's because if you picked X, you'd get 1 with probability 0.4, otherwise 0, and if you pick Y, you would get 1 with probability 0.6 and otherwise 0, so Y is better. And let's see, is this an equilibrium? So let's see if anyone regrets. Never regret your dominant strategy. Here, you're going up, you're getting 2. If you went down, you would get 1, so you do not regret. And player 2 doesn't regret. You're better off with Y, given both up, and it's not going to matter down here. We'll never reach this point. So this is the square equilibrium. But of course, I haven't proved this is the only equilibrium. I've just proven if righty goes up, that has to be the equilibrium, and no one regrets, so that is an equilibrium. So let's put a triangle around down and see if there could be one here. So now in this equilibrium, what does player 2 do if up is played? Well, he knows he's here, so he goes with X. He goes with X. And then, does anyone regret? Player 1 doesn't regret because he's getting 1. Had he gone up, he would have gotten 0. And then no one else will regret. So we will end up with left, we end up here, and right, we end up here. So this game has 2 equilibria. And let's do the final game of this homework set. Sorry. Okay, the final game of this problem set, if we're player 1, up gives you 5 or 8, down always less, so up is a dominant strategy. And for right, up gives you 0 or 2, down gives you 1, so no dominant strategy. For player 2, here you'd want X, here you'd want Y, and for down here it's the same as before, so here we're indifferent, here you'd want X, but X is just weakly dominant. But since, again, as with last game, we know since only lefty goes up, if someone goes down, it will be assumed to be righty. So that means if down is played, it is reasonable for player 2 to go with X because he'll figure he's here. Okay, now what we can do is we actually can figure out what player 2 should do if up is played, unlike the last game, because player 2 will say to herself, either just lefty is going up or both lefty and righty are going up. If just lefty is going up, I want to play X. But if lefty and righty are going up, I also want to play X, because if both went up, right, if you play X, you get 1 with probability 0.6, 0 with probability 0.4. Well, if you played Y, you get 0 with probability 0.6 and 1 with probability 0.4. So now, in this equilibrium, you don't have player 2, if up is played, knows she wants to do X, and all she has to know is this. She doesn't have to realize what player 1 is going to do here. Now, what does righty want to do in this situation? Righty wants to play down. So we end up with, if nature goes left, we end up here. And if nature goes right, we end up here. And thank you. You, by the way, now have enough to do the next homework. So please do homework 8. Goodbye.